So today we are going to dockerize these applications to create this Docker file. And I have seen like a lot of the YouTube tutorials where they will like show you such format for creating the Docker file for the Spring Boot applications. So what they're doing is like I'm using the Java 21 version. So they took the image as OpenJDK 21, then the working directory of your choice. Then what they are doing is copying the target anything in the target file into the app.jar files. So this is the target file which contains the build jar files. But this is not the correct way because the target folder is the temporary folder, or we can say that this folder is generated when we build the project. If I delete this like target folder, what will happen? We have to like run this project again. You see this, like the process failed and the project is no longer working. Start the project again. We'll see that the target folder will again be generated. So essentially, the working of a Docker or a container is like the container should generate the target folder, and we should not copy the target files. If we do like this, every time we run the container, we have to, or every time we change any files in this sources, we have to copy this target into this app.jar and then run the container again. So that's why this is not the best practice. What I will do is, this is the one I have modified for my project. I took the image and changed the working directory. You can choose this directory to be anything you like. Then one more thing to notice in this project is, this is the whole project. What are the things that this project required? So I'm using Maven, which is popular for the Spring Boot applications. So the things which are important, you will not find this config.d in your project. I have added this. Let's ignore this for a moment. This Docker file, Docker compose YML. Apart from these, we have pom.xml. It contains the dependencies of the project, which are the main part of this application. Then mvnw, which is used to download the dependencies and run the project. mvnw.cmd is the source. Apart from this, the .maven folder, which contains the configuration about this Maven. So what we'll do is, when I took the image from the Docker Hub, I have set the working directory. Now I want to copy this .mvnw.cmd into the current directory. So the format is like the path in the host environment, which is the like this IntelliJ and path of this mvnw.cmd. This dot tells the current working directory inside the container, which is this working directory. So this file will be copied into this folder, Spiritual Sakti API. Next, we will copy the mvnw into the same current directory. Next, we will copy the .mvn inside .mvn folder. We can write this like this, inside the current directory into the .mvn folder. But this is fine. Then we will copy the dependencies. Now, this directory has only this CMD file, this mvnw and .mvn folder, and these dependencies. Now, what we'll do is, ignore this line for a moment. Now, what we'll do is run this command. We run this command .mvnw. We want to install the dependencies. Now, after installing the dependencies, our project, or we can say this directory, Spiritual Sakti API, is still missing something, and that is the source files. So now we will copy this all the sources in our current directory host environment into the source in the Docker container. Now we'll run this command mvnw package and skip test. What will this will do is, it will generate the target folder. We don't have to like copy paste this target. Let the Docker generate this target folder for us. This expose command, Docker run the container, it will expose this port to which the host or anything, for example, the browser can listen to. When I deploy this using the Docker file, I want not the 1990 port, but 1992. So I have exposed the 1992. Now everything is over. We have all the necessary files. We have installed the dependencies. We copied the source. We created the jar files. We exposed the port, and finally, we want to run the jar file. Now, one thing you notice here is that I have written Java jar target folder, which is generated at this line. But inside this, I have written this name. Now, if you will see the target here, when it is generated, you will see the names can be spiritual Shakti, snapshot, etc. etc. Like the name might not match this name particularly. So, what you'll have to do is go to your pom.xml, and inside this build, at the last, you'll write this name, this file name, final name, which will be the name of your jar after the build. So you can rely on this name that when I build, this will be the name which is generated. So I have written this name. Now is the time to see like is it working or not. So open your terminal, and before this, make sure that your Docker desktop is running, because running the Docker desktop will start the Docker engine, which is required for the Docker containers to be running. So Docker run, and this current, this dot means that look for that Docker file in the current directory. So Docker run, Docker build. So let's wait for some minutes, and you will see that the image is correctly built. And one more thing which I didn't tell you about is this chmod plus x mv and w. So the thing is, when the like this Docker is running on locally, like I'm using right now, this line is not required. But when this container is deployed on some machine like AWS or somewhere else, those machines are like there, it will not give this execute permission to this mv and w file, this file. So if you have used the Linux machines, you know that not all commands are executable. If you create a script, you have to provide the execute permission to the script. But when I run this locally, the Docker engine itself give the execute permission. So locally it is not required. But if you are deploying this container on some host, then you will have to like write this execute permission. You have to give this execute permission. So you can see like I already built this image. So that's why okay, one more thing I want to tell you, the steps in this Docker file are important. For example, if I change anything into these sources, uh, if I write this line here, this will not be efficient. So what Docker does is Docker caches or hash the steps. This copy is also a step. This is also a step. So each line is a step. So if I change the source file, it will see that okay, the working directory is not changed. So it will do the cache. It will use the cache. These files are not changed, so nothing will happen. This is also nothing, so it will use the cache. These dependencies will also not run again. This command will not run again because the pom.xml file is not changed. So this command will not run again. Since the sources, we have changed something in the sources, this file will run again. And then anything after this, this command will run again. If the change occur here, everything after this command will run again. So that's why the copying of the source, it has to be in the ordering so that the Docker container and the build process will be faster. So you see, these files are cached because I have built the container earlier and I have not changed anything. So working directory is cached. All the copy commands are cached. Form.xml is cached. This permission has to run again. Dependencies has to run again. Copy of the source file and this. If I build the container again to show you something, look, the copy commands are all cached. Now you'll see that the permission didn't run again. The dependencies are also cached. Copy of the source is also cached, and package building is also cached. So the image building 0.0 point 0 seconds, and that's all because of the ordering of the commands I've written in the Docker file. Now to see if the container works or not, let's see. Docker image ls. So you see this about a minute ago I have created this container. Okay, one more thing, you can give tag to your images. When you build a container, you can write -t my API, something like this, and you'll see that now your image has a name, Docker image ls, about a minute ago, and this is the name. Now you can run this API Docker container run, and to show you it is working, I will run it interactively, my API, and you will see that the container is working fine. The build process worked very well.